In this math tutorial, we'll be having a look at calculating the surface area of a triangular prism. Now, this can get a little bit tricky, especially if not all the information is given, and I'm going to show you two methods today in order to work it out. By first using the nets of the triangular prism, or working with the nets to get your answer, as well as just working from the 3D shape itself. In our first example, all the information is given. It is to calculate the surface area of this triangular prism. We have the 12 feet, the 5 feet, and the hypotenuse that is 13 feet, as well as the height of this prism, which is 19 feet. We are first just going to quickly fill in all the gaps in this shape. I'm going to this extend all my lines so that I just complete this shape. Next up, I'm just going to write down my formula that I will be using. It's 2 times the area of the triangle, adding the surface area of my first rectangle, as well as the area of my second rectangle, and then the area of my third rectangle. Now, where is all the shapes in the object? Well, let's start then by first marking our triangles. On my triangles, I'm just going to mark in orange. So I'm just going to do this. I'm going to say there's my triangle. There is my second triangle at the back. They are identical, so I'm just going to do 2 times one of these triangles. Next up, I'll be using blue for my first rectangle, and I'm going to use this one in front here, the bigger one of the two. That's number 1. Then I have my second one. Let's do that green. This one, I'm going to do the one at the back. And then finally, let's use purple for my third, which is this bottom triangle right here, which I will be using. And these are the shapes. Next, I just need to write out each formula as well. So I'm going to say, all right, it's 2 times half times the base times the height, that is of the triangle, plus length times breadth of my first triangle, plus the length times the breadth of my second, plus the length times the breadth of my third. Right, now I can start by feeding in the information. I'm going to say it's 2 times half times the base. The base is 5 feet. Let's just write 5 to save space. And the height is 12 for my triangle. Plus, for my first rectangle, which is blue, and I've used the big one here, it is 13 feet times 19 feet. 13 times 19. For my second rectangle, the one at the back, I have 19 feet, because this side is 19 as well, times 12. So the length is 19 times 12. And then finally, for my third rectangle, the purple one, the bottom one, I have 19 times 5. Now this doesn't matter. The order that we write the length of the bread really doesn't matter because we are only going to use one side, and both sides are equal in length, and the opposite sides are equal in length. So it really doesn't matter. But if you really want to do it really accurately, remember to write the length is the longer side and the breadth is then the shorter of the two sides. Next, I'm going to calculate. So it's 2 times a half times 60 plus 247 plus 228 plus 95. So 2 times a half times 60, we know half of 60 is 50, so 2 times 50 is 60, plus 247 plus 228 plus 95. And remember, my answer will be in feet squared. If I add all these up, I will get to 650 square feet. So this is my first method I can use to get to the surface area of this triangular prism. My second method involves first taking apart the shape. Now if I take the shape apart, I can always just generally remember it's going to be a rectangle, and across it's going to form a trapezium. Now I can go and just fill in all the information that is provided to me. 19 and then 13 for these sides. Now I can go ahead and fill in the ones that are the same. So this is the same, 19 is the same. This is going to be straight through the same, 19 as well as 19. The height of the triangular prism is 19. Now I can go ahead and fill in the rest of my information. I know my short side here was 5, so it will be the same on the other side as well. And then this height, the height here was 12. So there I've got 12 and 12. This part here will be the same as my base of my triangle. So this will be 5 and this will be 5. And then finally, this here will be the same as my hypotenuse. So it's very important to remember that these ones here, filling in the gaps, these will be the same. These lengths will be the same. These two, that can get a little bit tricky with this method. Now that we know what our measurements are, we're just going to slightly change the way we are going to use the formula. So first of all, I'm going to write down my formula. I'm going to say it's 2 times the area of a triangle plus the area of the large rectangle that I have here. And that means that I'm going to have 2 times half times the base times the height, and I'm going to add the area, which is the length times the breadth. But in order to work out what the length is, I need to first get the perimeter of the triangle. This is very important. So the length will depend on the perimeter of the triangle. Now, what is the perimeter of the triangle? Well, the perimeter of a triangle will be adding all my sides together. So that means I'm going to have, so the perimeter of the triangle will be 5 plus 12 plus 13, and that will give me 30, or 30 feet in this case. Now that I know what the perimeter of the triangle is, I can now feed that information into the length. So in this case, I'm going to say, alright, 2 times half of the base. I know the base of my triangle was 5 times the height, which in this case is 12, plus the length that I've worked out with the perimeter of the triangle will be 30, and then I'm going to multiply it by the breadth, which in this case equals to 19, which is in fact the height of the prism. Calculating these values, I'm going to again get here 2 times half times 5 times 12 will give me 60, because half times 5 times 12 gives me 30, times 2 gives me 60, plus 30 times 90, which gives me 570. Adding these two numbers up will give me 650 square feet, which gets me to the same answer. This one's a little bit more trickier because we have to remember what we have to add and how we have to use the perimeter of the triangle in order to find the length of the very long part of that triangle that forms when we roll out this 3D object into a net shape. So I would definitely suggest rather learning how to do this first method properly than using the second method, but both is equally good to use. It will just depend on how you perceive and how you understand and work with your numbers and your shapes. In this example, we also have all the info given, but this time it is a more fuller shape. So how do we go about then working out the surface area? Exactly the same way. First, we are going to just flesh out all the information that is not present, like so. And there we have our full shape. And now we are going to apply with method 1 our rules once again. So we're going to say 2 times the area of a triangle plus the area of the first rectangle plus the area of the second rectangle plus the area of the third rectangle. Okay, now let's go mark in. Here's our triangle, and remember we'll be using the height that is formed from our right angle right here. So we will be using that to work out our 2 triangles there. And then we have the first rectangle. I'll be using this one, the green one here. Now let's do that one, that's the first one. And then I will be using this bottom one here as my second. And then finally, I'll be using this one at the back here as my third rectangle. Let's do that one in orange. Okay. So let's go fill in all our information. 2 times a half of the base is 12 times the height, which is 8, plus my first triangle. Difficult to see now, but this was the first one here, the one that I could actually see, is 10 times 14 inches. 10 times 14 plus my second one, the bottom, is 12 times 14. And finally, the one at the back will also be 10 times 14 in this case. 12 times 8 will give me 96. Half of 96 will give me 48. And 2 times 48 will again give me 96. Plus 10 times 14 is 140, plus 12 times 14 will give me 168, plus another 140. Adding up all these values will get me to 544 square inches. I can also use my second method. The only difference is the information that we are going to feed into the triangle here. Let's first just fill in everything that we know. We know that the height is 14, surface will be 14, all these lengths of these sides will be 14. And now I'm going to go ahead and fill in my triangle. I know that the base of my triangle is 12, and that means that this side here will be 12 as well. But I now should remember that both the other sides of a triangle is 10 and not 8. And I'm just going to quickly fill in that first, and then the height of the triangle there, that is 8. So I'm not going to use that to fill in one of the sides like within the previous example. And then I know this adjacent side here will be 10 as well. Now I've got all my information correctly filled out so that I can actually do the calculation and work out the surface area correctly. Next I'm going to write down my formula, and my length is dependent on this triangle right here. So I'm going to do that just first here at the top. I'm going to say, okay, that's 12 plus 10 plus 10. The perimeter there will give me 32. And now I can go ahead and plug in all the rest of the information. 2 times a half times base. The base of the triangle is 12 times the height. And this height is that 8. This is where I'm going to use that 8. Plus the length is the perimeter, which is 32, times the base, which we know is, in this case, the height of the prism, which is 14. And now if I work this out, I'm still going to get, this is still going to yield 96, just like we had in our previous example there. And then this one here will give me 32 times 14 is 448. And adding those together will give me 544 inches squared. So this one the same, just remembering what information we need to carry over and how they should look when we use the net shape. In my third and final example, I'm going to look at a scenario where we have a side missing. So we have a triangle, but not all the lengths of the sides are available. In this case, we see that the hypotenuse isn't available. But if, for example, we had the height or even the base that wasn't present, but we had the hypotenuse, then and one of the other sides, then we could just as easily work it out by manipulating the theory of Pythagoras. Now, I'm first going to start, because I need that information, I'm first going to start by working out what is this side, what is the hypotenuse. And I'm going to call the z because I'm now first going to apply the theory of Pythagoras. So I'm going to say x squared plus y squared equals z squared. And now I'm going to plug in the information that I know. I know that x is 8 squared plus 6 squared equals z squared. So 64 plus 36 will equal z squared. So 100 will equal z squared. Z will then be the square root of 100. And that will equal 10. Now that I know that my z here is 10, I can now fill out my triangle with all the information. So drawing in the sides that we don't see, and then adding all the information. This will be 10, this will be 14, this will be 14. The opposite side here will be 8 again. And the opposite side here will be 6 again. Now that I have all that information, I can go ahead and work out this triangle either by using method 1 or then by using method 2, by filling in the correct information. Remember the differences. If we have an L-shaped triangular prism, we will be using the height as one of the side lengths. But if we have a triangular prism, we will not be using the height. We will be using the sides that is given to us. Because it is a triangular prism, it means that both the sides will have the same lengths, like in example 2. Thanks for watching, and I do hope that you found this video helpful in working out the surface area of a triangular prism, whether it would be triangular or L-shaped.